Hello there ladies, gentlemen, boys and girls. In this video today I'd like to talk about the deep cycle SISES Battery. And just as an assurance to people, I've not nicked off with this project, taken the money and spent it on beer. I've actually spent it on a real battery. This battery cost $180. It is, by orders of magnitude, bigger than this little battery here, this little Sentry that I got, from my dad's shed. This Sentry here can put out a maximum of, as it says here, 100 amp hours at 12 volts. Now what this means here is that this battery can produce about, well, I don't know, it can produce about a kilowatt, which is 100 amps, for 1 hour. It can produce easily about 200, amps and maintain that for about half an hour. This battery, is definitely, entirely suitable for this particular project, and basically here you're paying $2 for this battery, $2 per amp hour, since this cost about 180 something bucks. So this battery, yields quite a very substantive amount of power, not to mention that you can get maybe 12 or more of these and then wire them up to get, say, 1200 amp hours. But this battery alone can provide about 100 something amp hours, and I'll put it this way, it's more than suitable for this particular project. So I'd just like to keep you guys informed on how the project's going, and that's really that there all is to it. The only real steps that I need to make is, of course, creating a containment structure for this battery and installing the necessary fuses between the charge controller and the inverter to ensure that there is no overcurrent in the system, which may potentially cause a fire. Now, excuse the shoddy camera work, but as planned here, this is indeed the solar panel that we're actually going to use to charge that battery. What I'm planning to do is to basically create sort of a level surface underneath here, and I'm thinking about putting the battery down here as well as the inverter and charge controller. Now this system, we're going to of course have to put some tarp around this to provide sort of an external shield, and we're going to put the battery inside of a special containment structure accompanied by a lot of the other pieces of electronics, and we'll be sure to of course make videos about how we do this and how of course you can do it, so that you people can actually see how we construct the how we actually of course construct the system. Now another thing that I did want to bring up quickly here is that one of the Kickstarter supporters made a very kind donation, and his name is David Waldrop. Now the reason why I'm mentioning his name is because he chose a reward where I would of course shout out basically bring out his identity and thank him personally for what he's done with this project. Now, as for the other people, I'll put it this way here, I'm very, very appreciative of their contributions to the Kickstarter. However, I'm not certain whether or not they would, necessarily be a fan of me releasing their identity online. David Waldrop has given, his expressed consent by selecting the reward for me to do so, so I'm going to go ahead and do it and have done it. But apart from that, and apart from the thank yous that I need to send to David Waldrop through releasing his identity online, that's all I can really say from there. But basically here, this system, this is of course where the DC side of everything will go, and I'm thinking about making sort of a circuit box of sorts for the AC side out of the inverter. The only complication is with the inverter that I currently have is that it's a modified sine wave, which may cause some troubles with some of the smaller electronics like phone chargers. So I mean, it's entirely on the table that I can swap that out later on, but yeah, I'm pretty confident we can reach the target of 1.5 kilowatts and maintain it for a few minutes. Anyways guys, enough of my rambling and enough of my rant of sorts. I'm going to go on and basically do some quick saving and grab some the rest of the equipment that's required for this project, and I hope to put it all together relatively soon. That's all guys, see ya.